All right, here we go. And let's take a look at number one. So on number one, and by the way, this is more lens practice. And what we're doing here is going over some of the problems I gave you so you get more practice with lenses. And we're going to look at number one. So here I've given a focal length that's 10 units. It could be centimeters, could be meters, could be millimeters, could be anything you want it to be, as long as we use the same units for all of them. So I'm just going to put units here. That means that the focal length, which I've marked a focal point here, is the length from that focal point over to the center of the lens. So this is 10 units. We'll notice it says SO. The object distance is 30 units. So the candle, we think of our lab, and this is the candle. This is the top of the candle, and our candle is 30 units away. And it looks like this is pretty good. This distance here looks about 1/3 of this full distance here. So we have a nice picture with the original information. We could choose to do the math first, or we could choose to do the picture first. I'm going to go ahead and do the picture first. So light coming from the top of the candle leaves the candle in all directions. Some goes this way, this way, this way, this way. We're going to pick 3 directions that it goes. I'm going to pick one that's going parallel here. And when it hits the lens, it gets refracted. And it gets refracted such that that parallel light gets turned and goes through the focal point on its way. On the other hand, light that leaves the top of the candle and goes through the center of the lens continues on its merry way. And finally, light leaving the top of the candle that goes through the focal point will hit the lens, turn, and go parallel. And we'll notice that all 3 of these special rays converge at a point here where we could put a piece of paper and get a real image of the candle. Notice it's upside down. One thing we notice is that if light came from the top of the candle in some other direction, let's say it went in this direction and hit the lens, it would get refracted and it would also converge through that same point. We're only showing 3, but actually any light leaving the candle that hits the lens will subsequently get refracted and go through that same point right here. And that's why when I put a piece of paper here, I can get a focused, projected, real image onto that piece of paper. Okay? So given these 2 pieces of information, it's easy to calculate some other things. Let's take a look how to do that. If with this thin lens equation, I put in 10 for F, and I put in 30 for SO. I have fractions, which isn't that fun, but I can take the 1/30 to this side, plug it through my calculator. Don't forget to do the reciprocal, and you should easily find that SI is 15 units. Let's take a look if that's what we got. If the focal length is 10 units, which is this distance here, so this is 10 units also, then this 15 makes sense, right? That looks good. It's about 15. And when you go to do your math, if it doesn't match what you did with your picture, it could be that you were just a little sloppy with your picture, or maybe it's an indication that you need to go back and check your math again, see if a mistake was made. Okay? Finally, we're going to look at the magnification. The magnification here is given by negative SI over SO, so I can put in 15/30. And the negative in the equation is important. It gives us a negative magnification, which tells us that the image is upside down compared to the object. And that's certainly what we saw here when we did the ray tracing. So that negative makes sense. The fact that it's 0.5 tells us that the image is smaller than the original object, which it looks like it's about half as big. So that turned out very nicely. And that's how we go about drawing these with a lens. I'm going to scroll down real quickly and just do the mirror example. This is with the same exact data, so that if you did this again mathematically, you get all the same numbers. So this is again 30. This is 10 from the focal. And this is 15 after we calculated SI. So the only difference really is how we draw the rays. So this principal ray going parallel, when it hits the mirror, goes through the focal point on its way. This one at the bottom here, I'm going to say, is it goes through the focal, hits the mirror, comes back out parallel. Okay, so that's this one. The last one is the one that would have gone through the center of the lens. This one comes and hits the center of the mirror. It will reflect with exactly the same angle, and it should also go through that same convergent point. So those are the three principal rays if it's a converging mirror instead. One thing I'll mention is that notice this is a converging lens. So that's convex. This is a converging mirror. So that's concave. It's important that they're both converging, which is why our focal length here was a positive number when we put in the 10 units. So that's number one with a good little review. Try some other ones. I'll see if I can get a video in for one of the other problems as well. Thanks a lot.